Hello everyone, I'm Max and welcome to our lesson 5, Quadratic Equations. So in this lesson, we are gonna cover what quadratic equations are, how to, solve them, what the solutions are, how to change between different forms of quadratic equations, which we will see in just a second. And I will also transition more into graphing because I won't officially start with graphings like linear graphs and everything, but I will start to incorporate more and more vocabulary from graphs and slowly explaining more stuff, but there will be no specific lesson tailored to directly graphs. Well, there will be one for exponential graphs, but it won't be like how you would expect it. Don't worry, I will make sure everything is as it should be, so you can get as much interest in maths without it coming off too complicated. So since this is the last lesson, before we officially go into what I consider graphing lessons, like sequences and everything, I do suggest you take a notebook or open Desmos calculator /website /app, whatever you want to call it. Desmos, D-E-S-M-O-S. It helps you graph out stuff. So take a notebook or use this app to follow along, or if you actually want to learn something useful, I recommend a notebook. However, the app is also not that bad. Quadratic equations are polynomial equations, which means they have multiple terms where the variable, in graphing cases and this case especially, is x, and the terms have different exponents of x. So, for instance, this C unit has no x, which we could write as x to the power of 0, because any number to the power of 0 is 1. Then we have x to the power of 1, x to the power of 2, and if we had x to the power of 3, it would be another type of polynomial equations. But quadratic equations, they are a form of a times x squared plus b times x plus c equals 0. Here, a, b, and c are constants. So first we have to know a couple of things before we start solving them. A cannot be 0, otherwise we don't have a quadratic equation, we would have a linear equation, which most of you probably know by now. It's a straight line, just a line that the steepness is determined by the b or k coefficient, and the number that the graph intersects with on the y-axis is c, in just a linear equation, of course. So we must, for the quadratic equations, of course, assume that a is not 0. Well, what can it even be? A can be greater than 0, which gives us this type of shape. So an upward open parabola. The word for this shape is parabola. And if it's open up, it's convex, which is not important for this sake. And the vertex, which is the point at the extreme top or the extreme bottom, is right here. So the lowest point of the graph, where a is greater than 0, is called a vertex. And if we turn it around so that a is less than 0, it's facing downwards, so it's open down, it's concave, and the vertex, however you pronounce it, is the top point, so the maximum point we can have. Now, there are 3 common forms of quadratic equations. The first one you already know is the standard form. The second one is factored form. So if we remember back to equations, I mentioned Vieta's law, which is what we apply here to get the factored from standard. But I'll show you that in a couple of slides, so no need to get confused that much. But what each letter means: a is the coefficient from the standard form. I do not know why the font has changed. X is just x. R and S are zeros. So they are the x values of the intersections of the graph with the x-axis. I'll show you on an example so you don't have to get confused now, but R and S are basically x values of where the graph crosses the x-axis. Okay? Hopefully that was clear. If not, we will see the examples. And now the vertex form. I am butchering the word, I apologize, I do not know how to pronounce it. But this form, again, has a outside and then a bracket of x minus p squared plus q. So we know that the vertex is the maximum or the minimum point. Okay, so the coordinates for the vertex can be calculated. For instance, take the average of 2 x values from 2 points that have the same y value, or do some fancy maths we will do later. But this form, if given to you, basically tells you the vertex, like the point that it is. So here P represents the x coordinate and the Q represents the y coordinate. Now, as I mentioned, that neat little trick, you can find 2 points on the graph that have the same y value, which is not that hard. Then you take the average of the x values. So basically you find the halfway point from one x to the other, and that is the x value of the vertex. So putting it into the equation, basically that's how you get the coordinates of the vertex on a graph. Now let's try to even see how to get this vertex form, like what P and Q are, because these are different constants. Of course, R and S are too, but we'll get to that in a second. First, P and Q in vertex. We know that they are coordinates of the maximum/minimum point of the graph, but how do we get to them? First, we break the brackets squared, so we have a square of a difference. We multiply each term with each term. We break it apart. Now, I multiply each term with a, so I have 4 separated terms, so I can see what we have in common, or to get the formula closest to the standard form, which is ax squared plus bx plus c. And now I see that there's an x here, and there's some numbers in front of it, okay? Let's say that this equals to b, and these 2 terms equal to c. So let's write it down. Why can we say that? Because this looks almost exactly like the standard formula. And if we replaced these letters/numbers, these constants, with another letter, we would get the standard formula back. So this term has no x in it, or these 2 terms have no x in it, so they can be grouped together and be called a c. So the constant that has no x value next to it. Hopefully you are still following. Now let's take out P and see what the value of P would be. And the same for Q. We isolate P, divide by minus 2a, and we get P is minus b divided by 2a. And when we isolate Q, we get c minus a p squared. Now we insert P into the p squared, and we get this pretty nice formula, but if we extend it further by combining on the same division line, so we multiply and divide c with 4a, so we can... Basically, it's the same as doing 1/2 is changed into 2/4, because you multiply both sides of the fraction line with 2. Same thing we do here, so we can combine all of it on one fraction. Then I move the 4ac divided by 4a to the right, and I get minus b squared plus c. And then I multiply it all with minus, so I can have 1 at the start of the bracket, if that makes sense. Basically, this minus sign here is purely decorational for now, because it will come in handy a bit later. Maybe some of you already recognize this type of formula. Maybe some from the memes, maybe some know it. If you don't know it, that's okay. We will cover that later. But now let's get to the main point of the forms I want to cover. Conversion from standard to factored form. We use factoring. Oh, our beloved factoring. This is like the 4th time we're using it by now, so hopefully you all know how to do it. First, we look for common factors. Then we use methods like trinomial factoring and Vieta's rule. Oh, my bad. I should have used high capitalization here. And then we set each factor to equal to 0. So you will see what I do when I go by and solve it. For instance, we have an example number 1. X squared minus 5x plus 6. So for me, this is obviously the easiest one to use the Vieta's rule on, because 6 is 3 times 2, and 5 is 3 plus 2. So we see that we have a minus 5, so it's minus 3 minus 2, and if we multiply them together, we get plus 6. So we easily break this down into x minus 3 times x minus 2. So here you see that each factor equals to 0. We use the property rule. When multiplying with 0, the entire thing is 0. So if either of these 2 brackets is equal to 0, the equation is correct. Even if this one is equal to 17 million, doesn't matter. As long as one is 0, That's all we want to have. Okay, for example number 2, we have 2x squared plus 7x plus 3 is 0. So I set the template in which I will insert the numbers, and we break it down. So first, we copy 2 here into one of the brackets, doesn't matter which. We will just fill a and b correctly after. Now we have to find 2 equations. So the first one is for the 3, b times a has to equal to 3, and 2 times b plus a has to equal to 7. Hopefully you still remember from the last few videos where we did exactly this thing. We have these 2 equations. We know that 3 can be gotten only from multiplication of 3 and 1 because it's a prime number, and 7 can be added up if we have to multiply one of these 2 with 2. We only have 2 options, so it's 2 times 1 plus 3 or 2 times 3 plus 1. And we know it's the letters, so 2 times 3, so 3 has to be b, and 1 has to be a. Okay. And now if we truly wanted to go back and follow the factored form, where a is taken in front of the brackets, we could divide this bracket with 2 and get x plus 1/2, which if you see on the graphs, like so, I solved it here, you see that minus 1/2 is actually one of the zeros, which kind of makes sense, doesn't it? If the y value is 0, and we have 2 parts that either if multiplied by the other becomes 0, when 0, then we know that these are the roots or the solutions to the equation when y is 0. I hope that you can see this logic behind the factored form, that when you have 2 units that only have multiplication in them, so bracket times bracket, and the result is 0, you have to have either one as 0 to have the solution, which gives us 2 solutions, but we already know that for the highest level of exponent in the equation, that's the biggest amount of solutions that we can have. So x to the power of 3 means we can have max 3 solutions, and so on and so on. Let's learn to convert from standard to vertex. First, we factor out a from the first 2 terms, so ax squared plus bx. Then we have to complete the square with, this is a tiny hint, but yeah, we have to, this bracket we have here, we have to complete this to be able to get a square of a sum or square of a difference. And this formula I mentioned here is just a recommendation that you can use to make it easier if you don't see what numbers you have to add in or take away to get the square. After that, we simplify and write in the right order, and voila! Now, the example 1 is y is equal to x squared plus 6x plus 5. Since a is 1, we don't have to take a out from these 2 terms, we just put the brackets around them. And now we see that 6 is a sum of 2 of the same numbers, so 3 plus 3. And if we remember back to when we did equations, I mentioned this rule that x squared plus 2ax plus a squared is equal to a plus x altogether squared, square of a sum. So that 2ax is an important term here, so if we divide this with 2ax, we would get that the value is 3. A would have to be equal to 3, and the last term is equal to 3 squared, so we would have to do 9. But let's take the suggestion I used. Let's use the b divided by 2a squared. We fill in a and we fill in b. We get 6 halves times 6 halves is 3 times 3, which is 9. Now, we add and subtract 9 inside the brackets, and then to take this 9 that we don't need out of the bracket, we would multiply it with a. But since a is 1 here, we just move it outside of the bracket for free. And then we can combine the rest here as the square of a sum. Then we just calculate minus 9 plus 5, and this is our vertex form, where the vertex point is minus 3, minus 4. Do keep in mind that this here has to be a minus for the positive number, since, yeah, the value of the bracket has to be 0 to find specific points. In this case, vertex as the lowest one, assuming that 4 is just how low we moved it. If there was no 4, the vertex would intersect with the x-axis, and these would be 2 zeros on 1 point, which we will get to later on. I just hope that you can see this logic behind that whatever you insert as x has to make the brackets value or the result be 0. Now, solving quadratic equations, aka finding zeros. First, we solve by factoring, or as we know, the factored form, the best one for zeros. We equate y to 0, we factor the equation and assume zero product property. So multiplying a number with 0 gives us 0. Let's use this on the first example. Y is x squared minus 7x plus 12. We equal y to 0. Then we write out 12 as a product of two numbers and minus 7 as the sum of two numbers. I already went ahead and knew that 4 times 3 and 4 plus 3 is 7 and 12 in this way. So I break them down into the brackets. We get them factored in. These are the zeros. So if we put x as 3 or x as 4, we would have 0. So these are the solutions. And that's how easy it is to solve by factoring. Then we have an example like number 2, where we have 2x squared minus 8x, and we're missing the c. What do? Well, we don't worry, because we just take out the greatest common divisor, so 2x. We're left with x minus 4. And this can also be treated as a separate bracket, so one of the zeros would be 0, because if we put 0 here, it cancels out no matter what the bracket is. And the other one is 4, so whatever we put as 2x doesn't matter, because this one is 0. We can also graph it out and see, yes, the roots are on points 0, 0 and 4, 0. We did it correctly. Next up, the same type, almost the same one, and we do the same process. Y is x squared plus 5x. We take out x. We are left with x plus 5. So again, one root is 0 and the other one is minus 5. Now that we remembered how factoring works, we can move on to more interesting methods, like solving by completing the square, and what that magic even is. When factoring is difficult, we use completing the square. When we want vertex form, we use completing the square. And we have to remember that when we do this process, we have to add and subtract the same value to complete the square. Hopefully you understand why we can do this from the equations lesson, last lesson or 2 lessons ago. Whatever you do to one side of the equation, you must do in the same way to the other. So if we were to add 9 on both sides, if we were to move that 9 back to the other side, we would get plus 9 minus 9. Let's stop with the theory and go into actual examples. Now, we have y is x squared plus 4x plus 1. Factoring this would probably be very hard. If it's not hard for you, congratulations, you probably don't need my content, other than for amusement. But I do appreciate you for sticking by. Now, let's see what we can do. First, we equate y to be equal to 0, and then we move the 1 from the right to the left, so we get minus 1. Then, of course, we can turn around the side, so we have x's on the left. Next, we add 4, because we have to complete this to the square, and if I take the term with just the x, so x to the power of 1, divided by the 2ax, then the a would have to be equal to whatever is left. So it may be confusing. If you divide, this term should be standardized to be written as 2ax. So 2 times a times x. And if you divide this by that formula, the result would be 1. So if we changed a instead of 1, so we swap them around, multiply by a, divide by 1, we would have a equals to this divided by 2x. So whatever is left is the number we have to square for it to become what we need to complete the square, as the name suggests. So 4x divided by 2x is 2. 2 times 2 is 4, so we have to add 4 on both sides, or add 4 on left and take away 4 on the left as well. But that's why we put 1 to the right, so we can just add 4 on both sides. We get plus 4 on left and plus 3 on the right. We get the square of the sum on the left and 3 on the right. Now we square root. Now this is new, we didn't do this before, but we just drag the root over the left side and over the right side. And it's important to be careful here, because if we had 3 plus 1 or let's say 3 plus a or something, we couldn't just root it simply, because you cannot break apart the root of a sum. So if we have the square root of a times b, that is equal to the square root of a times square root of b. That's not the same for sum and for addition and subtraction. So we have to be very careful for either the brackets, everything in the bracket to be to some exponent, and the opposite side to being just one term. So have the least amount of terms possible. That's all I'm saying. Now we square root, and we have to remember that anytime we take a square root of something in a way like this, so we have a value that we know is a square, and we're calculating the root of it, like so. When we root it, we have to add plus minus, because this x may as well be negative 7,000. And if we just use plus, we would lose that one of the results. That is very important to keep in mind. Root of 3 is not plus minus 1.73, whatever it is. But if we have x squared and we know that the result is 3, we know that x is plus minus 1.73. I hope you can see that type of logic here, because if we did the other way around, when you square something that has a negative sign inside the bracket, so it's also squared, like we did learn a couple of lessons ago, that negative sign is lost. So it's important that when we're doing the other way around, we sort of account for that and we just add this plus minus, meaning we have two solutions, one with plus and one with minus. This isn't the official symbol. The official symbol for plus minus is plus like above and minus under it. So it's like these two lines, just move them further apart and just make the top one into plus or the bottom one into plus, whichever is better for you. But now we have x plus 2 is plus minus square root of 3. We move 2 to the right and we get that x1, so the first solution is minus 2 plus square root of 3, and the other one is minus 2 minus square root of 3. I would attach Desmos, the graph, but some why the app decided it doesn't want to show more than one decimal point, and I did try everything I could, but it just doesn't let me. So if you want to make sure that I'm not lying to you, you can plug these two numbers in calculator, plug the equation into the graphing software or graph it out yourself, and then compare your results and make sure that I'm speaking the truth if you don't want to believe me. Or you can believe me and we can go on with the lesson. Now, example number 2. This one has much higher numbers. Y is 3x squared plus 18x plus 27. Now, we can again assume that y is equal to 0 since we're finding the zeros. And now that left side is equal to 0, we can divide or multiply by any number as long as we don't lose the value of x. So we divide by 3, and we're left with x squared plus 6x plus 9. And now we see that this is already a square, so we break it down together. We have x plus 3 altogether squared, which means that the 0 or the root is a double root, which is also the vertex of the function, and it is located at minus 3, 0, which we can see on this graph. We solved it correctly. And this is the marking you can use. X, 1 and 2 is minus 3. The third way, or the next way of solving this is with quadratic equations, which help us find zeros. You may know this formula already from memes or everything, but this is the one I've been talking about. Minus b plus minus square root of b squared minus 4ac, altogether divided by 2a. Now, there is a couple of things you have to know about this equation. First is the discriminant, a big D, and it determines or tells us or predicts the numbers of results/zeros that the function is gonna have. But it only predicts which. If you want the exact number of, if you want the exact value of the zeros, you have to calculate it through this equation. But if you wanna just analyze the function to see if it intersects with the x, you just solve for discriminant. Discriminant is under the root, so the value of it is b squared minus 4ac, and it has 3 possible outcomes. If the value is positive, so b squared is greater than 4ac, then we have 2 different roots. So the function's vertex is under the x-axis and it's facing up, or it's above the axis and it's facing down. So it has 2 intersections with the x-axis. If the value is 0, there is 1 double root, so the vertex itself is a 0, and there's only 1 intersection with the x-axis. And if the value is negative, well, we have complex roots, 2 of them to be precise. We can calculate them by taking the root of it, but we're not at complex numbers just yet, so I'll save that for later. But to make it easier for me to solve this equation exactly here, I decided to separate the top and bottom markings. That way, of course, this is not officially correct, but it's also not wrong, because you can just equate the top part with some variable and the bottom one with some variable, calculate separately, and then combine them in simple fraction. You can do whatever you want as long as you make sure that in the end this is equal to the result you have. But yes, I will mark t, so big T will mark the top part of the fraction, minus b plus minus the square root of the discriminant, and the b will be marking 2a, the big B, of course. Now, how to get the quadratic formula? You can skip this ahead. I will put this in the timestamp or however it's called. So you can skip it if you don't want to know, but it's a very nice thing to know, in my opinion. So, first we take the standard formula and divide it with a. We get x squared plus b divided by a times squared, plus c divided by a is 0. Now we subtract ca, so we isolate x's on the left and we get the numbers on the right. And we, as we did before, complete to the square by adding b divided by 2a squared. Now we see that this on the left is the square, so the square of a sum, and this on the right is just this on the right. So we put this together as if we were doing for the vertex form, and we move this order around so we have the positive number first and we take away ca. Okay, this is a bug. Just ignore this here. I guess the image got corrupted and it just overlaid with the random part of this. Now I just reordered the right side to have, basically I expand the fraction with 4a, so the denominator, aka the number under the line, is the same, which allows us to combine fractions if we are adding or subtracting them. So I expanded it, I can combine them into the same fraction. Oh yeah, I made sure that 4aa is actually written as 4a squared. Then I combine them into the same fraction. You don't have to do this step, I'm just dumb and forgot that I can do it nice together first. Now I have a bracket with the square on top of it and one term. You see, it was important for us to combine this, because otherwise we would have a root over two terms. Now we technically have just one term. Now we rooted, we have plus and minus. Now let's clear this up a bit so it's easier to see what we're doing. But since we took the root of the square on the left, we have to put plus minus in front of the symbol. Hopefully that you're still following and it's not too complicated. So I clear this up a bit. Now, there's a cool property with multiplication and division under the roots, as I said before. So we can separate it. So the root of a fraction is a fraction of the roots. So I can root the top and bottom parts separately. I moved the b divided by 2a to the right. I solved the root under the fraction line that gives us 2a. And since both of these fractions have 2a as the denominator, we can combine them. Minus b is moved up, ahead, and we have a plus minus sign, which this is the correct one. Square root of b squared minus 4ac divided by 2a. And this is the correct formula. Now I just mark it correctly, x1, 2, because it gives us two results. And after you apply plus and minus separately, we just have x1, x2, and that's it. Now to use it, how do we even use this on an example? You may be wondering, and the solution is easy. You color or mark each number, so we know that a is in front of x squared, so in this case it's 1. B is in front of x, so in this case it's minus 2. And c is minus 3. I colored them so it's easy to follow along. I track separately top and bottom of the division line. So minus b plus minus square root of, I put multiple brackets so hopefully you don't get confused, b squared minus 4 times a times c, end of brackets, end of the root, and solve that. And for b, I solve 2 times a, which is 2 times 1. So 2 times 1 is 2, which is simple. Hopefully everyone can solve that. and minus minus 2 is plus 2, and then under the root we have minus 2 squared is 4, minus 4 times 1 times minus 3 is minus minus 12, which is 4 plus 12, which is 16, and now we have 2 plus minus square root of 16, which, again, we all know that it's 4, and now we just order these around, that top is 2 plus minus 4 and bottom is 2. We insert them as a fraction, so the top part is here and the bottom part is here. So for x1 we insert plus, for x2 we insert minus. We have 6 halves and minus 2 halves, which is 3 and minus 1, and we put them on the graph, the same formula here. We get that the zeros are actually x is 3 and x is minus 1. Example number 2. For this example, I will paste pictures because I have solved this in Word. Well, sorry, I solved it in LaTeX, or LaTeX, however it's called, and then I converted it into Word, so it was easier to screenshot, because LaTeX is just programming it, and it's much simpler to write such fractions and roots and all that, and Word is just easier to screenshot, although I could just save some time anyway. But yes, I write out each of the 3 constants. I insert them in the equation as shown here, so we put 3 instead of b, 3 instead of b, 5 instead of a, minus 2 instead of c, and 5 instead of a. Simply fill in the equation, start calculating under the root. 4 times 5 times minus 2 times minus 1 is 40. 9 plus 40 is 49. So we have minus 3 plus minus square root of 49 divided by 10. Hopefully we all know the basic multiplication tables, and that 7 times 7 is 49. So we can break that apart. We have minus 3 plus minus 7 tenths. And if we write that out using plus as the x for x1 and minus for x2, we get 2 fifths. So minus 3 plus 7 is 4 tenths. And if we divide both sides with 2, so divide top and divide bottom with 2, we get 2 fifths. And if we take minus, we have minus 3 minus 7 is minus 10. Minus 10 divided by 10 is minus 1. So 0.4, which is 2 fifths, and minus 1 are the zeros and the answers to the solution. Important things to keep in mind. Now, this is actually something very important here. Always, 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 again, the signs plus minus are always to be kept in mind. But this is especially important here. When you're taking a root of a square, so you know something is squared and has a variable in it, make sure that you account for plus minus. So if you're just squaring a number, that's okay, no need to do that. But if you have a writing with like a square value and you root it, keep in mind the plus minus, okay? You can also look up for yourself exactly when this applies and how to tell. But this is just the basics to get you interested in the maths. As everywhere in the world, if you want to learn something, it's best to do it on your own terms, on your own inspiration, on your own motivation. That's the word. But yes, next is when completing the squares, you have to keep in mind that you have to add and subtract the same value. So, as with equations, you either add on both sides the same value, so plus 9 on left, plus 9 on right, or if you're working on one side only, just make sure to have plus 9 minus 9. Basically, if you add them together, the result has to be 0. Same for multiplication. If you multiply the equation with something, you can multiply and divide at the same time, so that the factor is 1. So if you cancel out everything, it will be like you multiplied the equation by 1. And last but not least, a is next to x squared, b is next to x, and c has no x. Damn, poor c has never been in love. Just kidding. But no, this is important because sometimes you may get an equation which is like 4 plus x squared minus 3x, and many people get confused. I know for my classmates, they were confused. They just used the first number as a, the second one as b, the third one as c, and they got it wrong. So do keep in mind that certain rules have a reason for them, and that sometimes you may not always have the most polished task given in front of you. I could put it in a Minitest to test if you really did follow up or if you understand the topic, but I already made it and it's too late to change it because I already made the solutions and I'm about to record the solving process. But yes, if you'd ever come across swapped terms, make sure to keep that in mind. Well, I will put Minitest on right now as I ramble to the end of the video. Thank you so much for tuning in today. I hope this lesson was informative enough for you to pursue more into graphing, because graphing truly is a wonderful thing. You can graph anything as long as you have two variables. It's absolutely gorgeous. Physics, chemistry, whatever you do, you can literally put in an Excel, make a graph over everything and just enjoy that. Desmos, just have fun. That thing is amazing to just learn the effects of numbers, multiplications, additions on the graph. But yeah, as for the Patreon I mentioned in the last video, I got some interest, I got some people interested in it, so I will be making it. However, I will make it public in summer because I would feel bad making it like subscription and everything if I have no Minitests. But until then, I will make enough of them. Minitests from the videos, of course, will be posted up there, but I'll also make more Minitests, and I would hate to make a subscription service that offers nothing more so far. Yeah, so if I can wait 1 month and make it after that and already have a certain amount of Minitests, like 15 on a free and 28 on the paid version, that's still better than having 15 free, 15 paid, you know. Hopefully that makes sense. Anyway, thank you so much for tuning in. Have a great rest of the weekend, guys, and see you on our next quest. Bye.